morning to one and all. I am Venkadesham. I am going to discuss about some of the problems in the ionic equilibrium. Particularly here I am going to discuss about the pH calculation for the mixture of strong acid and strong base, and with the different proportions. Right. Here I am going to discuss one problem, that is in find the pH of mixture of 500 ml of 0.1 m HCl and 200 ml of 0.1 m H2SO4 and 300 ml of 0.2 m HNO3. Here HCl, H2SO4 and HNO3, these three are acids only, and acids they have taken in a different volume and a different molarity. For HCl I was calculated the normality N1. We have the relation normality is equals to small n into m. This is a n factor. This n factor for acids it is in a basicity. Basicity is nothing but the number of replaceable H plus ions present in the given acid. Right. So for HCl 1 is there, so that 1 into 0.1, this is a 0.1, and in the problem it is given as a volume V1 is a 500 ml. For H2SO4 I am taking that this is in a normality N2 is equals to, again H2SO4 there is a 2 replaceable H plus ions are there, 2 into 0.1, so that you will get 0.2, and its volume is given as a 200 ml. For HNO3 solution, and its a normality is equals to small n into m, again here also 1 into 0.1, and you will get a 0.1 normal, and its volume V3 is given as a 300 ml. And we have a formula to find out its a mixture of acids, and normality will get H plus ion concentration is nothing but normality, and this normality mixture of this all the acids with the different volume, we have the formula, that is N1 V1 plus N2 V2 plus N3 V3 divided by this is a V1 plus V2 plus V3. So N1 V1 you will get this is in a 500 into this is a 0.1, and you will get 50. 200 into 0.2, that is in a 40, and 300 into this is in a molarity is given as a 0.2 here, and you will get this is a 0.2. 0.2 into 300 you will get there is a 60, and whole divided by total V1 plus V2 plus V3, and here 500 plus 200 700 plus 300 total 1000 ml. You will get 150 divided by this is in a 1000, and 1 0 will get cancelled there, and I can write here 1.5 into 1 simplification 1.5 into 10 power minus 1. If I will take the pH value 1 minus log 1.5, here 1 minus this is in a 0.18 I will get, so that I can write this is in a 0.82 is a pH for the mixture of this all the three acids. Right. Next problem is find the pH of a mixture of 100 ml of 0.1 m HCl plus 100 ml of 0.2 m H2SO4 plus 100 ml of 0.1 m HNO3, plus further they have added the 700 ml of water. Right. So you can write down again for HCl formula is a normality equals to small n into m, molarity is given as a 0.1, 1 into 0.1 you will get 0.1, volume is given as that is in 100 ml. So for H2SO4 normality N2 is equals to, that is in 2 into its basicity is a n factor for H2SO4 is a 2 into 0.2 you will get as a 0.4, and its volume V2 is equals to again 100 ml. Right. For HNO3 there is an N3 is equals to, there is an 1 into 0.1 you will get as a 0.1, and volume here 100 ml they give. Even H2SO4 volume also 100 ml, even HCl volume also 100 ml. Total 300 ml is there, and for that they made it into the adding the 700 ml of water. Total volume is 1000 ml. Right. For finding its a pH, H plus ion concentration should be required. This H plus ion concentration is equals to normality. Here normality for the mixture of acids formula is N1 V1 plus N2 V2 plus N3 V3 by, here it is a V1 plus V2 plus V3. So here N1 V1 0.1 into 100 you will get 10, again 0.4 into 100 you will get 40, and 0.1 into that is in 100 means 10. Total 60 divided by this is in the 100. From that I will get this is in 60 divided by 100. I can write down this is a 6 into 10 power minus 2, and whenever I am writing it's a pH, or pH is equals to this is a 2 minus log 6. Okay, so log 6 value is a log 6. This log 6 value is a 0.78. Whenever the 2 minus 0.78, I will get this is in a 1.22 is a pH for this particular one. Next problem is find the pH of a mixture of 500 ml of 0.1 m NaOH plus 100 ml of 0.1 m calcium hydroxide plus 400 ml of 0.2 m KOH, and write separately for NaOH its normality is equals to small n into m, and here 1 into 0.1. 1 into 0.1, that is in a clearly it's a n factor for the sodium hydroxide. Only one replaceable hydroxyl ion is there, so that it's a n factor is a 1, so that 1 into 0.1, 0.1, and volume is given as that is in a 500 ml. For calcium hydroxide there is in a 2 replaceable OH minus ions are there, and it's a 2 into 0.1, it gives its a normality 0.2. Volume of the calcium hydroxide is 100 ml. For KOH normality is equals to, again its n factor is a 1 into 0.2, and you will get this is a 0.2, and its volume is that is 400 ml is given. So here this is a mixture of bases, mixture of strong bases, so that you can find its OH minus ion concentration gives rise to its a normality, and I can write which is a normality for the mixture of bases are N1V1 plus V plus N2V2 plus N3V3 divided by here V1 plus V2 plus V3, and N1V1 is nothing but 0.1 into 550, you will get 0.2 into 100, you will get as a 20, 0.2 into 400 you will get as a 80, all divided by total 500, 600 plus 400, 1000 ml, and you will get a 150 divided by 1000, right? So 15 divided by that is 100, that means 1.5 into 10 power minus 1. This is a OH minus ion concentration. From this OH minus ion concentration I will get POH, but actually we need to find its a pH, and you find POH first. From that you can find out its a pH, and I will get this is in a 1 minus this is a 0.18, and I will get this is a 0.82 is a POH, but here pH is equals to that is 14 minus POH. So 14 minus this is a POH is a, you got this is a 0.82, so that means this is a 13.21, that is in a 13.18. Right. Next problem, find the pH of a mixture of 100 ml of 0.1 m NaOH plus 200 ml of 0.1 m calcium hydroxide plus 200 ml of 0.1 m KOH. For the total mixture is added 500 ml of water, right? So they are asking to find the pH of this mixture of bases. For sodium hydroxide, molarity is given, you can convert its a normality N1 equals to small n into m, 1 into 0.1, that is in here is 0.1, and its volume V1 is given as 100 ml. For calcium hydroxide, this is a normality is directly they gave as a 0.1, and you can write down the 0.1 here, and its volume is a 200 ml. For potassium hydroxide KOH, N3 is equals to molarity they have given, convert into the normality 1 into 0.1. This 1 is a n factor, one replaceable OH minus ion is present in the KOH, so that's 0.1, and its volume is given as a 200 ml, and this total volume is a 500 ml. Again 500 ml of water is mixed, so the total volume will become as a 1000 ml. So this is a mixture of bases, no OH minus ion concentration equals to normality. And here we have the formula N1V1 plus N2V2 plus N3V3 divided by total volume V1 plus V2 plus V3 and water also. And here N1V1 0.1 into 110, here 0.1 into 220, again here 0.1 into that is 220, total of 50 divided by 1000, and you will get 5 into 10 power minus 2, right? So 2 minus log 5 value I am taking that this is 0.1. So log 5 value is this is simply a 0.76989 you will get. You can consider it as a 0.7, so that you will get this is a 1.3, and this is a pOH you will get. From that pOH you can find out it's a pH, and pH is equals to 14 minus pOH. Here 14 minus pOH is that is 1.3, so that I can write this is a 12.7 is it's a pH. The next problem is find the pH of a mixture of 100 ml of 0.1 m HCl and 300 ml of 0.1 m H2SO4 and 100 ml of 0.3 m barium hydroxide, and the total volume is made to 1 liter by adding the water, right? This is a problem. Here they have given the 2 acids and 1 base they have given, and that total volume is made to the 1 liter by adding the water, right? So in this problem, first we need to find the NV product of acid first, then followed by NV product of base, right? So in when we are finding the NV product of acid, 2 acids are there. You can write here NV product of acid HCl plus NV product of acid H2SO4, so that I can write here NV product of acid HCl 100 into this is in a 0.1 into 1 means again you will get 0.1, whereas in the 300 into this is in a 0.1 into 2. Why? Because it is in a H2SO4 is a dibasic acid, its a N factor is a 2, so that you will get and here 10, and by multiplying this one you will get 60, total of 70 milli equivalents you will get. This is a milli equivalents, whereas in the case of NV product of base, only one base is given, that is a 2 into its 2 is this is a diacidic base, its a N factor is a 2 into its molarity is 0.3, and its volume is given as 100 ml. So when we are multiplying this one, this you will get as a total 60 milli equivalents, right? So but here NV product of acid is more than the NV product of base. That's the reason total solution, the resulting solution should be acidic in nature. Definitely if it is acidic in nature means we need to find out its H plus ion concentration. How you can able to find the NV product of acid minus NV product of base divided by total volume. Total volume is made to the 1 liter by mixing it with water. So that 70 minus 60 divided by 1000, 10 divided by this is in 1000, 1 0 will get cancelled. This is simply a 10 power minus 2. H plus ion concentration 10 power minus 2 means simply we'll write down its pH is equals to 2, right? Next problem is find the pH of a mixture of 500 ml of 0.1 m HCl and 100 ml of 0.1 m H2SO4 and 400 ml of 0.1 m calcium hydroxide. Here also in this problem also there is an HCl and H2SO4 are the acids mixture, and a base also mixture, that is in a 400 ml. Okay, in this problem also find out the particularly there is an NV product of acid and NV product of base. Check that whether the NV product of acid or base which is dominating. Based on that we'll find out its H plus ion concentration and OH minus ion concentration. Here NV product of acid, actually 2 acids are there, 500 ml into 0.1 plus there is an 100 ml into normality of H2SO4 directly they have given 100 into 0.1. So 50 here plus 10, total 60 milli equivalents you will get. Whereas in the case of calcium hydroxide NV product of base, only one base is given and its acidity is 2 and 0.1 into 400 ml is given. So when we are simplifying this one you will get 18 milli equivalents. So here NV product of base is more than the NV product of acid here. So that a resulting solution is going to be a basic in nature, and definitely from that we'll calculate that it's OH minus ion concentration here. OH minus ion concentration equals to 80 minus this is in 60 divided by total volume is 1000 ml, and 20 divided by 1000 you will get and simplification 2 into 10 power minus 2 is the OH minus ion concentration, and from this I will get that there is a 2 minus log 2, and log 2 value is a 0.3010. You can take it as a 1 place of decimal, that is a 2 minus 0.3, 1.7 you will get. Whereas in the case of pH is equals to 14 minus POH, you got only a POH, they are asking the pH, and pH is equals to 14 minus POH, and here 14 minus POH is you will get 1.7. From that you will get there is a 12.3 is a pH value. Next problem is find the pH of a mixture of 8 grams of NaOH plus 680 ml of 1mHCl plus 10 ml of H2SO4, and whose density is given as a 1.2, and even its weight by weight percentage is given as a 49%, and the total mixture volume of the solution is made to the 1 liter with the water, right? Here they have given the one base sodium hydroxide, two acids, that is in HCl and H2SO4. Find out this normality, weight by gram equivalent weight into 1000 by V in milliliters. So substitute that the total volume, this 8 grams is dissolved in a total 1 liter of the water, so that you will get this is in 1000 by 1000, and 8 by 40 is a gram equivalent weight of sodium hydroxide, and simplification you will get 0.2 is the normality of base, and volume of the base we will take it as a NaOH 1000 ml. And even with the help of this 10 ml into density and percentage, we can find out its a normality of H2SO4. For that we have the formula, there is a 10 into percentage weight by weight into density divided by gram equivalent weight. Here 10 into percentage weight by weight, that is given as a 49, and its density is given as a 1.2, and simplify this one you will get 12, and its volume of H2SO4 10 ml they have given. And in the problem directly this 1mHCl molarity and normality will be the same, because it is a mono basic acid, and its volume is simply a 680 ml is given. This is a 680 ml. Okay, now you take that NV product of this acids. NV product of this HCl is a 680 into 1 680 plus even 12 into 10 120. NV product of acid total you will get, that is in 800 milligram equivalents. Whereas in the case of NV product of base 0.2 into 1000 you will get milli, this is in gram equivalents you will get, right? And here 800 and this one is a 200, so that acid is dominating. NV product of acid is more than the NV product of base, so the resulting solution is definitely it is an acidic, so that H plus ion concentration equals to, this is an NV product of acid is dominating, no, 800 minus 200 divided by 1000, and simplifying you will get 600 by 1000, and 6 into 10 power minus 1 you will get that. So from that pH equals to 1 minus log 6 value is a 0.78, and 1 minus 0.78 is nothing but 0.22 you will get, right? Next problem is find the pH of a mixture of 37 grams of calcium hydroxide plus there is an 360 ml of 1mHCl and 10 ml of H2SO4, and whose density is given as a 1.4, and its weight by weight percentage is given as a 49%, and the volume of solution is made to a 1 liter with water, right? In this problem also they have given first there is a base, and then two acids are given, H2SO4 and HCl, and you can find out NV product of acid and NV product of base. If based on that we will find out its a pH, right? First I am calculating a normality of calcium hydroxide, and weight divided by gram equivalent weight into 1000 divided by its a volume in milliliter. So weight is 37 grams is given, gram equivalent weight is so that you will get here particularly there is a gram equivalent weight for the particularly calcium hydroxide is that is 74 is a total molecular weight, 74 divided by this is a 2, that means this 37 only will get 37, again here it is a 37 will get cancel, so that simply 1 molar or 1 normal you will get for the calcium hydroxide. Gram equivalent weight is gram molecular weight for the calcium hydroxide is a 74, but actually it is a diacidic base, divided by 2 you will get its a gram equivalent weight, that is in a 37, and 37 will get cancelled, so that its normality is 1. Volume of calcium hydroxide is 1000 ml. In the same way, you can find out its a normality of H2SO4. Further, they have given its a density, weight percentage, and its a volume. By using that, you can find 10 into weight percentage is and 49. Density is given as a 1.4, and a gram equivalent weight is that is in a 49, because it is a 98 divided by 2, 49. And simplification, you will get 14. Volume of H2SO4 in the problem is given as a 10 ml. Whereas the normality of HCl and molarity of HCl is same, because it is a monobasic acid. Volume of HCl is that is in a 360 ml, right? So NV product of both this H2SO4 and HCl you can take. So this is a 360 ml into 1, 360, and you will get this is in a 14 into 10 ml, 140. Total 500 gram equivalents, milligram equivalents you will get. But in the case of particularly base, NV product of base here 1 into 1000 and 1000 milli equivalents you will get. 1000 so milligram equivalents you will get, right? So but here actually NV product of base is more than the NV product of acid. I can write here NV product of base is more than the here NV product of acid. So the resulting solution is a basic. For the basic solution, I can find out its OH minus ion concentration is equals to, and here it is in 1000 divided by 1000 minus 500 divided by, this is in a total volume is 1000, it is there. So from that I can write this is in 500 divided by this is in 1000, and that means this is a 0.5. 5 into 10 power minus 1 also we can write. So from this I can find it's a POH. So POH is equals to, I can write this is in a 1 minus so log 5. Log 5 value is that is in a 0.69 and 89. You can take it as a roughly 0.7 minus this is in a 0.7. This is, so you will get this is a 0.3. POH is a 0.3 means I can write here pH is equals to, so here 14 minus 0.3. So that means this is 13.7 is pH for this.